हाय गाइस, क्या हाल चाल है भाई? हाउ आर यू? कैसे हो आप लोग भाई? दिवाली कैसी रही आप लोगों की? हाउ वाज योर दिवाली? आई होप इट वाज गुड. इट रेन्ड ओवर हियर इन बैंगलोर. सो कल भी बारिश हुई थी ऑन द डे ऑफ दिवाली. माइल्ड ड्रिजल, बट ऑन एंड ऑल, like, uh, it was great. Like, it was good. This time it was good. Last time it had rained very heavily, so the whole Diwali was spoiled, but this time it was good. Okay. So uh, I welcome you again to the Catalysis channel of Vedantu, and this is the last lecture of the carbon family. Until now, we have had lectures on S block, hydrogen, water, hydrogen peroxide, um, group 1 and group 2, uh, P block, that is group 13, and this we have already covered a part of group 14's lecture. So this is the second part of carbon families lecture. Okay, this is the second part of carbon families lecture. Now after this lecture, the whole inorganic chemistry section of 11th standard will be done. इनऑर्गेनिक केमिस्ट्री जो 11th स्टैंडर्ड के लिए है वो कंप्लीट हो जाएगा हमारा विद दिस लेक्चर. ठीक है? सो विदाउट वेस्टिंग एनी टाइम, लेट्स स्टार्ट टुडेज सेशन and let's see what we have to study today. Most of it is the takeaway of the previous session, and please do remember that in the last session we had discussed physical properties, some very general chemical properties. Today we will discuss little bit about some specific chemical properties of certain compounds and some special compounds of carbon and silicon. So let's start. We had discussed in the last class that carbon reacts with halogens to form halides. Also other elements react, but दो तरह के halides आपको मिलते हैं. So class, this class of compounds, the halides, come in two categories. एक होते हैं dihalides and the other one is tetrahalides. Dihalides are being found predominantly by the lower member of the group because inert pair effect operates. They tend to not form tetrahalides to a very large extent. The tetrahalides are not that stable as the dihalides. For carbon, the tetrahalides are more stable. Now, when it comes to carbon and silicon, the tetrahalides can be hydrolyzed. अब देखो, hydrolysis of tetrahalides is a very vital, very important reaction. ये CBSE में कितनी बार पूछा गया है. Now इसको समझने की कोशिश कीजिए. कार्बन का जो टेट्राहेलाइड है, let's take CCl4. CCl4 is non-polar. Okay, CCl4 is non-polar, so it does not react with water. This class of reaction where a halide reacts with water and the halogen is removed and water does that is known as substitution reaction. ये substitution reaction आप organic chemistry में पढ़ोगे. This substitution reaction does not take place in cold water. CCl4 will react with water only when it is present as superheated steam. Okay, CCl4 will react with water only when it is present as a superheated steam. But will all chlorine atoms be removed? No. All chlorine atoms do not get removed. Only 2 chlorine atoms get removed, and it results in the formation of carbonyl chloride, COCl2. ये COCl2 को, the commercial name of COCl2 is phosgene. Phosgene is a poisonous gas. It was used in World War I. It's a poisonous gas. This gas is obtained from chloroform when it reacts with oxygen as well. So ये chloroform oxygen reaction से भी ये phosgene हमें मिलता है. Phosgene is poisonous. Now, how does a substitution reaction takes place? So this H2O reacts with silicon and it displaces chlorine. And since it displaces chlorine, chlorine goes out as Cl minus and OH gets attached over here. Now, how many chlorine atoms can you see? There are 4 chlorine atoms. So, 4 OH groups surround it. You might ask that, sir, why 4 OH groups are surrounding it? Why not 4 OH groups are surrounding in carbon? Because around carbon, arranging only 2 OH groups is a big challenge. Because of the repulsion of the lone pair of electrons present on oxygen atoms, this compound is itself quite unstable. This is quite unstable. And so water will be removed. Water will be removed from here so as to form COCl2. ठीक है, आप अगर suppose you are given this compound, then you remove a molecule of water to form COCl2. Okay, yeah, Shashank, what is your doubt? So this is all about the hydrolysis of tetrahalide. Now, as we have already seen, the first member of every group shows anomalous behavior. Some behaviors are a little awkward, a little weird. Now what are the anomalous behavior of carbon, and why these anomalous behavior comes up? So the anomalous behavior is because of a small size, high electronegativity, high ionization energy, and unavailability of d orbitals. So anomalous behavior of carbon is because of 4 things: small size, high electronegativity, high ionization energy, and unavailability of d orbitals. ये d orbitals जो हैं ये silicon onwards सब में present रहते हैं. Silicon and silicon onwards सब में present रहते हैं. Carbon cannot extend its covalency beyond 4. Other elements can extend it beyond 4. Okay. Carbon has the unique ability to form p-pi multiple bonds. P-pi multiple bonds means the double bonds or the triple bonds. These carbon can form C double bond C, C triple bond C, C double bond O, C triple bond N. ये सारी चीजें कार्बन बना सकता है, but other elements cannot do this. Okay. Heavier elements do not form p-pi bond, because for forming a pi bond the atoms have to come really close to each other. So small atoms can come really close to each other, large atoms cannot, because उनमें repulsion ज़्यादा हो जाते हैं nucleuses के बीच में. Okay, forming pi bonds require small orbitals, small atoms which can approach easily, because the pi bonds are formed by lateral overlap. If the distance between the atoms would be very large, then pi bonds would be formed ineffectively. Okay, so the first compound of carbon that we would study is carbon monoxide. Carbon के 3 oxides होते हैं: carbon monoxide, carbon dioxide and carbon suboxide. CO, CO2 and C3O2. The 2 oxides that we have to study for which are there in the syllabus are carbon monoxide and carbon dioxide. So what is carbon monoxide? What does carbon monoxide do? Or how is carbon monoxide prepared? So carbon monoxide is prepared by reacting carbon and oxygen at high temperature, by dehydrating formic acid. This is a very important reaction. Dehydrating formic acid. You can see that we have dehydrated it. Dehydration of HCOOH. Okay. Next, carbon is being made to react with water between 473, the 200 degree until like almost 1000 degrees के बीच में reaction करेंगे, then we'll get water gas. Water gas contains carbon monoxide. And if I react carbon, oxygen, nitrogen, we get producer gas. Producer gas contains carbon monoxide and nitrogen. So you have to do further steps of separation to separate carbon monoxide in these two cases. However, the second one is the most commonly used method. Now, what are the properties of carbon monoxide? So, carbon monoxide is colorless, tasteless, it is insoluble in water. आपको इसका कलर भी पता नहीं चलेगा, टेस्ट भी पता नहीं चलेगा, and it is not soluble in water. Okay, it burns with a blue flame. Many a times you might have seen certain industry some chimneys in the industry. If you live close to industrial town, that there is a blue flame which burns at the top of the chimney. Okay, so this blue flame is due to carbon monoxide. It's a powerful reducing agent and it reduces oxides into their respective metals. हम कार्बन मोनोक्साइड को यूटिलाइज करते हैं मेटल ऑक्साइड्स को रिड्यूस करने के लिए. यू विल रीड मोर अबाउट दिस इन क्लास 12th and the topic would be metallurgy. You will read about how and at what temperature carbon monoxide is utilized as a reducing agent. Carbon monoxide forms complexes which are known as carbonyls. Again, something that you will cover in 12th standard. In 12th standard coordination compounds, you will read about metal carbonyls. So these metal like NiCO4, FeCO5, these are formed when these metals react with carbon monoxide. It is poisonous. Why it is poisonous? Because it gets absorbed in, or it gets trapped in hemoglobin faster than oxygen. So carbon monoxide reacts with hemoglobin and hemoglobin traps carbon monoxide in preference to oxygen. And if it traps carbon monoxide, you will expect that once hemoglobin goes to the blood cells, once hemoglobin goes to these cells, you should obtain you should find that carbon monoxide should go out and hemoglobin should return back to the lungs to get oxygenated. No, it will not happen like that. Okay, it will not happen like that. It does not leave hemoglobin, it actually precipitates hemoglobin, and so the amount of hemoglobin in the body decreases, and so your oxygen carrying capacity of the blood decreases, and so a person suffocates to death. The bond order is 3. However, the bond order in CO plus is more than the bond order in CO. In CO plus, the bond order is 3.5. Okay, 3.5. If you look at the Lewis base structure, you can see that the carbon atom has a negative charge. So because of the negative charge on carbon atom, it can be utilized as a Lewis base. Okay, Mohammed Khan, if you have any doubt, आप पूछ लीजिए. Okay, if you have any doubt, please do ask. Okay, carbon dioxide. Now, what are the various methods by which carbon dioxide is being prepared? कुछ एक methods बहुत simple है. एक तो method होता है कि you burn any organic compound in oxygen. An aerial oxidation of any organic compound will give carbon dioxide. If you react carbon with oxygen, you will get carbon dioxide. You pass HCl through calcium carbonate or bicarbonate, you will get carbon dioxide. Okay, you'll get carbon dioxide. हेलो हेलो मुबशर, क्या हाल चाल है भाई? By heating carbonates and bicarbonates. When you heat a carbonate or a bicarbonate, you will get carbon dioxide. Okay, the temperature at which this decomposition will take place will differ. However, when you heat carbonates and bicarbonates, you will get carbon dioxide. एक fermentation से भी होता है. आप ferment, if glucose gets fermented, you will get ethyl alcohol and carbon dioxide is produced. What are the features of carbon dioxide? It is colorless, odorless and tasteless gas. सबसे पहले तो colorless, odorless and tasteless gas है. Okay, it is soluble in water. Carbon dioxide dissolve होता है water में, and that is the reason you get soda water. But the dissolution is not that very easy. इसको dissolve करने के लिए you need a high pressure, and it's not very easy to dissolve it. Okay, it turns lime water milky. Okay, it turns lime water and baryta water milky. So lime water is calcium hydroxide, baryta water is barium hydroxide. If you pass carbon dioxide through it, you will get a white precipitate. Why are you getting a white precipitate? Because you are getting a carbonate. But if you pass excess of carbon dioxide, you will get a bicarbonate which will be soluble. Carbon dioxide acts as a Lewis acid because the central atom is connected to two oxygen atoms, and these two oxygen atoms are more electronegative than the central atom. Anything can attack at the carbon atom and the bond can break towards oxygen. Okay, and it produces greenhouse effect. If you have read about greenhouse gases, then carbon dioxide is one of the most common greenhouse gases observed around us. They help in trapping the heat and not letting it go. But if there is an increased amount of carbon dioxide, then more and more heat will remain trapped inside the atmosphere, and so the temperature of this earth will increase. Okay, sure. Now what is silica? Silica is SiO2. Okay, so आपने देखा होगा, it's written in watches that quartz. I hope you have seen this. That घड़ियों में लिखा रहता है quartz. Okay, so if there is quartz, quartz is made up of silica and silicates. Okay, it also used as a piezoelectric material. Piezoelectric material is a material which interacts with sound. Okay, which interacts with these mechanical vibrations. So this is piezoelectric. It is used in an ultrasound machine. एक ultrasound machine में quartz use किया जाता है. SiO2 is commonly known as silica. We already know this. You do not have to remember all these forms of silica. However, you have to remember what silicates are. So if you look at a silica molecule, silica is sand. जो sand आपको दिखता है वो silica है. Silica has extensive three-dimensional structure. It's so very stable that it is not soluble in water or any solvent, and it cannot be decomposed easily. Okay, it cannot be decomposed easily. I would say that if you want to react silica reacts with I would say very less number of compounds, one of them being HF. HF can react with silica. Some other bases, some acids can react with silica. But silica is fairly unreactive in most of the cases. That is the reason silicates, which are derived from silica, are utilized in making glasses. वो borosilicate glass, borosilicate जो glasses आते हैं, borosilicate glasses, they contain silicates. Now what are the reactions of silica? Can you see this? It reacts with HF to form H2H SiF6. It is hydrofluorosilicic acid. हाइड्रोफ्लोरोसिलिसिक एसिड ना वैक्सी दिखता है, वैक्स के जैसा दिखता है, वाइट कलर्ड and so that is the reason HF cannot be stored in glass bottles, because glass bottles will contain silica or silicates. It will react with HF. It will react with NaOH to form sodium silicate, calcium hydroxide to form calcium silicate. It will react with F2 to form SiF4, and it will give out oxygen. And it can react with carbon to form silicon carbide. Silicon carbide is a abrasive, it's a very hard substance and it is obtained by heating silica with carbon. Okay? Now what are silicates? Silicates are anions which contain SiO4 4- units. Okay? Silicates are anions which contain SiO4 4- units. Now remember that these SiO4 4- units can be attached to another SiO4 4- unit in multiple ways, depending on how many oxygen atoms are shared between any two adjacent SiO4 4- units. We identify different classes of silicates. ठीक है? So अब एक silicate को अगर आप देखो तो it's a tetrahedron. So certain corners of this tetrahedron can be shared. So on the basis of the number of corners which are shared, we have ortho, pyro, cyclic and ring, chain silicate, sheet silicate, three-dimensional silicates. So 1, 2, 3, 4, 5, 6. We have 6 types of silicates. If I take a orthosilicate is one जिसमें से कोई corner shared नहीं है. In this, SiO4 4- unit is present. Okay, SiO4 4- unit. This is known as the top view. If you take a tetrahedron and you observe from here, then you will observe this oxygen towards you and these 3 oxygen atoms arranged in the form of a triangle. You will not be able to see the silicon atom, so this is known as the top view. Okay, orthosilicate does not share a corner. But if you take pyrosilicate, okay, pyrosilicates will share one corner. Pyrosilicates will share one corner. One corner is shared. So then simple formula for this will become Si2O7 6- क्योंकि एक कॉर्नर शेयर हो जाएगा. They will share one corner. SiO. This will become, so these 3 oxygen atoms and these 3 oxygen atoms will now carry the charge. So it will be Si2O7 6-. ठीक है? This will be pyrosilicate. Orthosilicate, pyrosilicate मैंने बता दिया. Cyclic silicates will have 2 corners which are shared. Can you see that? For per silicate unit, 2 corners are shared. Okay, 2 corners are shared. If you are sharing 2 corners, you can result in the formation of a chain silicate or a double chain silicate. So आपने एक chain बनाया और दूसरा chain बनाया, you connect both these chains, that will become a double chain silicate, and they are known as amphiboles. Okay, they are known as amphiboles. General formula of such silicate is SiO3N 2N-. So remember that in case of silicates, you need to know the general formula. if you remember the general formula, you'll be able to. So in examination, what they will do is they'll give you the name of or the formula for the silicate, and they'll ask you that this silicate belongs to which class. So you have to look at the general formula of the silicate. You have to look at the formula of the silicate and compare it with the general formula for the given number of silicon atoms. If you get the formula in the form SiO3n2n minus, then it is definitely chain silicate. But if it is a double chain silicate, the formula will be Si4O11 6n minus. Okay, what are three-dimensional silicates? Three-dimensional silicates are formed by sharing all the four corners. Okay, if they share all the four corners, they will form three-dimensional silicates. And if they form three-dimensional silicates, example will be zeolite, quartz, feldspar. They are known as three-dimensional silicates. The next part is silicones. Silicones are alkyl organosilicon compounds. So they are polymeric organosilicon compounds which contain SiO. Why they are known as organosilicon? Because the alkyl group is connected to silicon. You can see that there are alkyl groups which are connected to silicon atom. So they are known as zeolite. Zeolite एक substance होता है which is utilized in I would say purification of water. Okay, zeolite is a chemical compound. Okay, इसका formula देखो लिखा गया है Na2Al2Si2O8.XH2O. ये इसका formula होता है. Okay, silicons are polymeric organosilicon compound. They're polymeric organosilicon compounds. How are they prepared? They're prepared by reacting when methyl chloride reacts with silica in presence of copper catalyst. Okay, various types of chloromethylsilanes are obtained. Can you see this? Chloromethylsilanes, you obtain such compounds. Okay, so what you have to do is you have to take silicon and MECl. You will get various types of compounds: MESiCl3, Me2SiCl2, Me3SiCl. All of these compounds are known as chlorosilanes. These chlorosilanes are hydrolyzed and they give rise to silicones. Okay? Alkyl means carbon containing groups. Okay, like CH3, C2H5, C3H7. These are carbon containing groups whose one valency is unsatisfied. They are known as alkyl groups. So you perform hydrolysis of such chlorosilanes and that will give rise to silicones. Okay. And what is glass? Glass is a non-crystalline form of quartz. Amorphous form है. ठीक है? ये जो glass आप देख रहे हो, this is a super cooled liquid. Okay. This is in fact in the appearance of this glass, though is solid, but it is a super cooled liquid. In fact, if you look at glass in old buildings, very old buildings, then the bottom part is thicker, the top part is thinner because it flows very slowly. और कोई भी अगर fluid के form में है तो वो amorphous ही होगा. So quartz is crystalline SiO2 when fused with silica, which is amorphous SiO2 without impurities. While fused silica, which is amorphous without impurities. Okay, so glass is usually sodium aluminosilicate. So yeah, or you can say sodium silicate. Glass is prepared by utilizing silica एंड सोडियम कार्बोनेट, बहुत सारी चीज़ों का को मिला के हम बनाते हैं. वी कैन मेक कलर्ड ग्लासेस एज वेल. Okay, so just remember that these are the oxygen atoms and these red dots are the silicon atoms if we look at the structure of glass. ठीक है? So remember that group 14 involves only this. इससे ज़्यादा group 14 में नहीं है. We have to be very very concise in our approach, very objective in our approach. इससे ज़्यादा हमें group 14 में पढ़ना नहीं है. Just have to go through silicates, silicones, glass. That's it. Okay. So with this we wind up group 14 and we finish the portion designated for CBSE or anything, CBSE SEC class 11th. Okay, class 12th in organic chemistry अगर आप पढ़ना चाहते हैं, समझना चाहते हैं, do follow the class 12th in organic chemistry videos. They are already present over there. Okay, so with this I end today's session and I hope you have enjoyed today's session. Please do watch other sessions which keep on happening on the Catalysis channel on regular basis. ठीक है? चलो, bye bye guys, have a lovely time and be safe.